So in the last segment, we talked about different kind of constant in our relational database model. So we have three type of constant. We talked about three main type of constant we talked about is key constant, entity integrity constant, and referential integrity constant. We have another type of constant known as domain constant. The domain constant means actually we can enforce the data type, we can enforce the type or um, some requirement for each value, for each attribute. Okay, for example the value of salary cannot be null. Okay, so we can say it's a not null constant. Okay, or the salary has to be like greater than, okay, the salary has to be greater than 30,000. So that's a domain constant, or also the data type. If we enter some record which violate the data type, that also means that's the data type of the attribute is also part of the domain constant. Now we can have a different type of constant known as semantic integrity constant. So let me give you an example. For example, in my relational database state, I want that the maximum number of hours per employee for all project each employee works is has to be 50 hours, 56 hours per week. Okay, so that's like a very complex requirement. The maximum number of hours per employee for all project he or she works on is 56 hours per week. Now, if you remember the whole relational database schema, actually I'm going to need a lot of tables to find out that whether the maximum number of hours per employee is greater than 56 hours per week or not. Okay, so I need employee table, I need project table. I have to count down like how many hours each employee is working in project per week. Okay, and the whole number of hours cannot be more than 56 hours per week. So it's a complex operation, and this type of constraint we cannot just enforce by declaring a constraint type. Okay, so all these constraint, key constraint, entity integrity constraint, and foreign key constant are also known as referential integrity constant. These three constant actually we can impose or we can force for each attribute when we are going to declare, when we are going to create a table, when we are going to create a relation. Okay, we can just enforce, we can just say that this attribute is going to have this constant. Okay, but this is a complex operation, and I cannot just enforce for a particular attribute this constraint. Okay, I need to write a like a complex operation or like a function. Okay, so SQL has a trigger or assertion. So using those trigger and assertion, we can express some of those constant, and we'll see just a brief example in section 5.2. Okay, so when we'll know about some complex SQL, then we'll see some example of trigger and assertion. Using some trigger and assertion, we can create like this type of complex constraint by writing a complex query inside that. Okay, which will check. All right, so for example, whenever I am going to insert a new project or for employee, that is going to actually run another query to check what is the maximum number of hours for employee for all project. Okay, if the maximum number of hours is greater than 56 hours per week, that is going to tell me that it is violating the constraint. Okay, so this type of special constant is known as semantic integrity constant, and here you can see that actually you can define your own constant. Okay, by writing the trigger and assertion, you can define your own constant. So let's talk about couple of relational update operation. So each relation will have many tuples in its relation state. So just to remind you, a relational schema means the list of relational schema means list of the relation with the relational diagram. Okay, Now the relational state mean when we have real data, in the relation. Okay, and the database state means actually the collection of all the relations with data in each relation. All right, now the relational database state is union of each individual relation states at a particular time. All right, so whenever the database is changed, a new state will be there. So for example, let's see, I have three employee 1, 2 and 3, and I have two department 1 and 2. Okay, these are my employee, these are my department. Okay, now with the data, this is known as database state. Now whenever I will do some update operation, means the update operation means any operation that will change the database state. For example, I insert a new employee record. Okay, that will be a total different database state. Okay, let's say I delete an existing employee from this table, that will be a new state. Let's say I am updating an attribute value for existing tuple, that will be also a new database state. So update operation means any operation that is going to change the database state is known as the update operation. So we are going to be familiar with these three update operations. Insert a new tuples in any relation in your database, delete an existing tuples from a relation, update an attribute value of existing tuples. So these are the three basic operations. Okay, now as we said that a database state is valid. Okay, a database state is valid if it doesn't violate any constraint. Okay, if it doesn't violate any constraint, and all we want to keep the valid database state. Okay, so whenever we are going to do an update operation, insert, delete or update, okay, we have to make sure that this update this is going to change the database state, but this cannot violate any constraint. Okay, so the integrity constraint that we are talking about, three integrity constraint and domain constraint. Okay, and we may have some semantic constraint, they should not be violated by update operation. So these three are the basic update operation: insert, delete or update. Okay, several update operations may have to be grouped together into a transaction. We may actually group together multiple update operation, and we can write we can actually run that as a transaction. Okay, so transaction means actually a series of operation altogether. Okay, series of operations altogether. All right, updates may propagate to cause other updates automatically, so this may be necessary to maintain the integrity constraint. All right, so the main idea of any update operation is that we cannot violate any constraint. Okay, and if any update operation violate any constraint, means that we have to take such operation. In any case, we cannot keep our database in invalid state. Okay, all right, now what happens if we write an update operation that is going to violate a constant? Now what happens? So first of all, we do not allow the invalid state of database. Okay, our database cannot go in invalid state. All right, means it has to always maintain the valid state. Now for example, I am writing some update operation that actually if it gets executed, it is going to violate a constraint. Now what I can do? Okay, and what the database, okay, I have some table, okay, and with each of the updated record, so what the database is going to, how the database is going to handle them. Okay, I am injecting a update operation. So this could be insert, delete, or update. Okay, so then how the database is going to handle if it's going to violate any constant. So we have actually these 4 operation. So these are the 4 operation by which the database can handle this violation of constant. First of all, it can cancel the operation. Alright, for example, let's say I'm going to insert a new record, but inserting the new record is going to violate a constant. So the database is going to cancel the operation. He will give you an error that okay, that is going to violate a constant. Okay, that is going to violate a key constant, so you cannot insert that employee. Okay, so this is the default operation. If you do not specify any other option, this is the default one, means actually you do any kind of update, so your database finds that's a violation, so it is going to just reject that. Okay, you cannot run that operation. This is the default one, and this is the most basic one. Okay, all right. Now the second could be like perform the operation but inform the user of the violation. Now depending on your problem, you may find that someone is trying to do something, you want to know that. Okay, some user is trying to run some operation, like for example trying to insert a user or insert something, but as a database owner, you want to know which type of operation the user is trying to do. So in that case, the database may allow the operation, but it is going to inform the user of the violation. Okay, so that you can actually manually you can correct that. So this could be one option. All right, another option is the trigger additional update so that the violation is corrected. Okay, all right, we will see a couple of examples for that. There are 2 options, cascade option and set null option. That means actually you are trying to insert a record, okay, that will violate a constant. Okay, so now you are going to allow this insertion, allow this violation. At the same time, you are going to trigger some additional update, so that the database automatically is going to trigger some additional update so that the violation is corrected. Okay, so for one insertion, the database may have to run multiple other insertion or deletion. Okay, so that at the end the database stays in valid state. So there are a couple of options for that, cascade option and set null option, and we are going to actually talk about that and see a couple of examples. Now the last one could be some execution of user specified error correction routine. For example, if the database is really busy and there are a lot of transactions happening, okay, in that case it can happen that you may allow some violation constant, but you are going to have a user specified error correction routine, like some functions written which will actually regularly which will monitor all the violation constant, and if there is any violation or error, you are going to correct them. Okay,